Good morning, ladies of calculus. Welcome to room 15. I was just about to say 16. Where? Learning never ends, even when we have people gone. We have how many gone today?
2.
3.
3.
Mackenzie, Emma, Elizabeth. But we continue with this. We left off yesterday. We started on antidifferentiation just yesterday. And so this is the very first problem we did. This one right here, and we were coming fresh off this note card 37, and so we're going to continue with that, and we're going to go to this problem 2, find the general solution. Now, do you remember what says general solution? Does it remind you of anything we've talked about in this class? It should remind you of something. Anything remind you of something?
What was the question?
General solution. Does that remind you of anything we've talked about in calculus class so far? Should remind you of something.
Are you serious?
Uh-huh. Yeah, we'll show you. I'll tell you in a minute. So, what it is, it says find the general solution of the differential equation dy over dx equals 3x to the negative 4 power. And so what we're trying to do is we're trying to find the opposite of the derivative of this.
Did you answer your question?
What?
About general solution?
No, I didn't. I'm going to answer it in a little bit.
Oh.
Yeah, so I just delayed answering it. So, but do you have an answer yet?
No.
You don't? Okay. Good. I'm glad you held me to it, though. That's really good. I appreciate that.
I just don't remember you saying anything else, and I was confused.
I need you to have a seat here. I need you to be right here. Yeah, I need you to be here for this. Don't want you to miss any key components of calculus class, which this definitely is. Okay. So anyway, we have dy over dx is equal to 3x to the negative 4 power. So we're going to cross multiply the dx. So we're going to get dy is equal to 3x to the negative 4 power dx. So do you see that? And what we're going to do is we're going to take the integral of both sides of this equation. And when you do this, this is something we get a general solution. Now, what we can do is, I'm just going to put it like this. So we're going to take the antiderivative. This integral symbol means the antiderivative. So that's what that means. And then what we have here on the left one here, the integral of dy is going to be simply y. So the antiderivative of that is y. And this one on the right side is going to be 3 times the integral of x to the negative 4th power dx. And so what we're looking for is this x to the 4th dx we're trying to find what thing do you take the derivative of to get x to the negative 4th power. Pardon me?
Like,
What do you take the derivative of to get x to the negative 4th power? Yeah, so it's going to be something x to the negative 3 power. So let's think that through a little bit. So Kaylee has her thinking cap on today. I appreciate that. So it's going to be something x to the negative 3 power. What x to the negative 3 power? So it's going to be negative. So let's take the derivative of this, d dx, and see if that's right. So we're going to get the derivative of that is going to be positive, right? Positive 3 x to the negative 4th power, right? we just want to have this, and so what do we have to have for that? We got to have it over 3, don't we? Or over 4. Let's go ahead and take it over 4 and see if that works. So we're kind of just experimenting around a bit, aren't we? So you go ahead and take the derivative of this. We're going to get, excuse me. Actually, it'll be 3, won't it? You want to subtract it, -4. Okay, yeah, ddx. You see, I'm trying to think through. So we take the derivative of that, we get 3 x to the -4th power. Is that right?
Yes.
But we want to set it up so we want to have just x to the -4th power. So we're going to have to divide this by 3, aren't we? So let's go ahead and do this by 3 and see if that works this time. So now if we take ddx of that, we multiply through, we get positive, negative 3 x to the -4th power over 3. That cancels out.
How come we want that to cancel out?
Well, you do, because you want to have this by itself, which we now have. And so what happens is, if we rewrite, we're set up that we can take this thing here, we can take away this integral symbol, and we can replace everything with this right here. So let's go ahead and do that. So we have y is equal to 3, and then we're going to take, replacing this thing right here, we're going to make this negative, I'm going to put in parentheses, -x to -3 power over 3. Okay, so we've replaced that. And so what goes away now? 3 over 3. And so what we have left is negative x to the -3 power. And we have to add the what? We have to add c. Okay, let's go back to what I was asking you about here. This is what I was asking you about, if you ever saw general solution. You see this? With indefinite integrals, our solution's general, so we should never forget to add the c. But if there's a point we can use, we substitute for x and y. With c solved, our solution's particular. So we have to add the c. So what we get here is our answer to this is y is equal to negative, and you can write it as -1 over x to the 3rd power plus c. And so this is what's called a general solution. Because just like the ones that Emma and you others were working on yesterday, we didn't know what that was. Yeah, it could be the derivative of any one of these things. And so what it is, for this particular one, there's some constant you don't know, that when you take the derivative of this whole thing, you're going to end up with this is what you're going to get. So that's what that is. So this right down here is going to be our answer to this. Now, does that seem pretty complicated?
Right now it does. You're just letting it.
Yeah, right now it does. But fortunately, just like there is in differentiation, a power rule, there's also a power rule of properties of integrals, which brings us to the next note card here, which is note card 38. And so you have all these rules for integration, and the main one we use for the power rule is number 4. And so we're going to employ all these rules here. And so let's just go ahead and do one of them, and I'll show you what that looks like. So this is the main one right here. So what we do for this one is the first thing I'm going to do, when you have a number in here, if you look at rule, okay, if you look at this one right here, at rule 3, if you have a number inside here, like we do in the first sample problem, we can take that number outside. So we can write this as -6 integral of x cubed dx. Does everybody see that? Okay, everybody taking that down, I hope?
You always separate the number and the...
I do, and what that does, you don't have to do it, but it makes your life easier, because what it does, it just boils it down to the essence of just having to work on this. So that's what doing that does, right? So that was a good question, good question. So what it is, you call it bump up and divide. So we're going to take bump up and divide, and so we take the power of x, bump it up, so 3 plus 1 is 4, and then we divide by 4. So whatever power you bump up to, you divide by. And then you add the c, and then the only thing you have left to do is you have a little simplification you can do. You can make that -3/2, right? So equals -3/2 x to the 4th power plus c. And what's a way you can check your work to see if you got it right? Take the derivative, exactly. So you guys are really ahead of the game. So d dx of -3/2 x to the 4th power plus c, and c is going to be any type of number, right? Any constant we don't know. So we take the derivative of this, and we're going to get 4 times -3/2 x to the 3rd power, and then the derivative of that is 0. So what we have left is -12/2, which is -6 x squared. Is that worked out? Okay, this is an example of that chicken and the egg t-shirt you have, what that does. Remember that? The chicken and the egg? All right, questions on that? Okay. We go on and do some more of these. Let's just go on here. Does that look, that's pretty easy to do with the power rule thing?
Yeah.
And so what you're going to do is you're going to get some practice doing it in these exercises. So I want you to go ahead and work on problem 2, and we'll review it. And again, now problem 2 again uses another aspect of, it's going to use this thing right here, that you can use this 5th rule to separate out like the next problem. You see what I'm saying? Well, just go ahead and work it out, and we'll cover it in a minute. Yeah, we'll cover that in a few minutes, okay? Okay, have you finished with this yet?
I think so, probably.
Let's go see what we get here. So what I would do with this one here, and what happens is you get more familiar with it, you can kind of skip writing down every step, but what you're going to have here is this going to be equal to x squared dx minus 10 integral of x to the fourth dx. Did you get that far on it? Okay, and so now you can just go ahead and integrate this thing by taking x to the third power divided by 3 minus 10 x to the fifth power divided by 5, and then plus c. And so if you simplify out, you get x cubed over 3 minus 2x to the fifth power plus c. And that should be your answer. That's what you got? Okay, very good. So that's it. Again, pretty simple problem. Did you test it by differentiating to see if you got the same thing? You wouldn't need, because if you can just quickly check it in your mind almost, can't you?
Yeah.
5 times 2, that's negative 10, and then x to the fourth power, check. So you can check in your head pretty quickly. All right? Questions on this one? Okay. Okay, yeah, do this one here. Do problem 3. And what that's going to be is, in calculus friendly form, I'd write that as 1/4 x to the 1/2 power dx. That's what I would do. That's the first thing I would do. So just like the power rule of differentiating is really bread and butter, essential skill for calculus, the power rule of integrating is a similarly helpful tool to make your calculus life easier. Okay, are you ready to look at this now?
Yeah.
Okay, so what we have here is we do the same thing. We have 1/4, and we're going to get rid of this. So we have x to the, what's a 1/2 plus 1?
3/2.
So 3/2. So you're going to divide by 3/2, right? And then plus c. And what you have, whenever you do this, a way to do this, and you can do this quickly in your head when you have a mind to, is you can just multiply by the reciprocal of that. So we can just turn this fraction upside down, x to the 3/2 plus c, and just simplify this out as much as you can. So you're going to get, you get 1/6, yeah. So you get 1/6 x to the 3 over 2. And you can write that back in rational form if you want to, which is going to be, I think, square root of x cubed, is that right? Plus c. So 1/5 square root of x cubed plus c is how you'd simplify it back into this. And then you can take the derivative of that. Let me write that down a little more legibly if I can. Square root of x cubed plus c. Okay? And again, so we should never forget to add the c, right? Questions on that one? So I want you to do number 4. And I think we can do number 4. Yeah, you can do that. And you'll want to, for this, use that number 5 rule to separate things out, to break it down, to look at it, make it easier. To me, what we're doing today, the mechanics of what we're doing today, is one of the easier things we do in the calculus class. Yet, the skill of it is so essential to being able to function as a user of calculus that we're going to slow it down as much as you need to so everybody knows how to do this. So are you finished with this one yet?
Yeah.
Let's go ahead and look at it. So basically what you're doing here is, if you separate this out into 2 adjacent fractions, you're going to get x squared over x squared. Dx plus 3, we'll just say integral of 3 over x squared dx. Does that look right so far?
Yeah.
So what we get here, when we simplify, we get x squared over x squared will cancel each other. So we have integral of dx plus 3 integral of x squared, or x to the negative 2 power dx. Does that look right? And so now what we do is we take the integral of dx is going to be what? Let's look back at our rules, because it's one of our 5 rules that we initially came up. Integral of dx is? Integral of dx is 0, let's just see. That was one of the rules here. Yeah, so it'd be this one right here. Integral of dx is x. See that?
Yeah.
Second rule here, that's what it is. So integral of dx is x. And then plus 3, and then we take what's going to be added 1 there. We're going to x to the negative 1 power divided by negative 1 plus c. And so for that, we're going to get x, and we're going to get minus, it's going to be 3 over x. Is that right? Plus c. So this is going to be, this will be our answer. Did everybody get that? Questions on that one? Okay. So now we get into note card 39, which is particular solutions, which gets back into what our song is. And basically what it is, to find a particular solution, you need an initial condition. And so you're going to need more information to be able to solve for what C is. Because these things we had without, if you remember what we did at the beginning of the year, we had these integrals, and with these integrals we would have numbers up here. Remember that? We had like from 0 to 5 and all that business, remember that? When you don't have any numbers here, when you have the numbers here, it's called a definite integral. When you don't have any numbers here, it's called an indefinite integral. And so we get back, it's going back to the calculus song. Within the finite integrals, that's indefinite integrals. Our solution's general, so we should never. Okay, but if there's a point that we can use, we substitute for x and y. With C solved, our solution's particular. And that's exactly what we're doing in this particular note card. So here we have a particular solution right here, and it's passing through 2, 4. And so what we're going to do is this y prime, we're going to rewrite that as dy dx equals 3 x squared minus 1. So how are we going to go ahead and find a particular solution for this? What's the first thing you want to do? Take a guess, take a wild guess, somebody. So I see thoughtful gazes happening here. Any wild guess?
Find the derivative.
Okay, that's a good thing. But even before that, so that's a well, we have to manipulate the derivative. So what we're going to do is cross multiply the dx. So we have is dy is equal to 3x squared minus 1 dx. And I parenthesize this to get dx times all this. Okay, now what's the next thing? let's go look at the note card, what it says. And I forget exactly how the note card words it, but I'm going to see here in a second. Okay, what we do, it says, you see where it says integrate f of x? That's what it's saying right here. That's the instruction it's giving us. And when we integrate f of x, we're going to find y equals big F of x. So let's do that. How do you integrate this? Okay. So I want you to go ahead and integrate this. And then, and so on the left side, hint, you're just going to get y. So integrate this on the right side, and we'll come back in a minute and continue to work this out. Can you do that? So for this, we're going to have integral of 3x squared dx minus integral of dx. Is that right so far? So y is equal to 3. We get x to the third power divided by 3 minus x plus c. And so that's going to cancel out. And so this thing right here, y equals x cubed minus x plus c, this one is called the general solution. And we call it general because it's for c being a constant, whatever it is. We don't know what it is. But what we do here, to find a particular solution, what are we going to do next? What does it tell us to do in the note card instructions?
Find y equals f of x using point x and y solve.
So we're going to use point xy, right? So what do we plug in here to work this out? And 4 for y. So 4 is going to be equal to 2 cubed minus 2 plus c. And so what's 2 cubed going to be? 8, right? So on the right, so we have 4 equals 8 minus 2, so that's 6 plus c. So c is equal to negative 2. And so what we do is we take this negative 2 and replace this negative 2 up here, right? So what we have is y equals x cubed minus x minus 2. And this one right here, the very bottom, is called a particular solution. Particular solution. So this is kind of a pretty elementary and pretty easy example of what the process is. Does that look like it's too bad? That shouldn't be too hard, right? So let's go look at another problem, see what they have here for us. At this stage of the course is where it's time for, so it's this one here, general solution, particular solution. That's from last year. Okay, find the particular solution of f prime of x equals 3 over x to the 4th power that passes through 1 comma 2. Yeah, so try that one out. And this is the part of the course where I'm going to give you some drills, some like homework assignments to get some more practice on doing this, right? Get more examples at this. After you get through, you can look up at the board and see what your solution to that is, see if you got the right answer on that. Did you get yours right?
I don't know why I always forget that you can move the x to the 4th. Just make it forget. I kind of means.
Oh, okay. So the first step is this one on the right. This is the work on the right. Get your general solution. Well, actually starting here on the left actually, and then working up here now. And once you get to this level here, have your general solution. And here's where you plug in 1 for x and 2 for y. And you find that c is equal to 3. And then you plug this 3 back into here. And you get your particular solution here at the very end, all right? And so that's probably a good stopping point for today, do you think?
Yeah.
Just about. Do you have any questions today on this? So we'll continue tomorrow, work through some more problems like this, and that'll be it. Say hi to Emma and Kinsey and Elizabeth. Hi. Good to see you.